right, guys, so we are going to start on example 3. So this one we're given side, angle, side, so the angle sandwiched in between the two sides. So if I look at it, it's angle A that I'm given, so the side that I'm missing is side A. So if I go back up to the top and I look at my equations, I'm missing side A. So because I'm given side, angle, side, I'm going to be using this column of equations, and because I'm missing side A, I'm going to be solving for side A with that equation. All right, so a squared equals b squared plus c squared, so I'm going to just start that out. A squared equals b squared plus c squared, so 9 squared plus 12 squared. And then I'm going to just read off what the equation is. Minus 2 times b times c. So 2 times 9 times 12 times cosine of angle A. And that's 25. Running out of room. All right. So we're going to have a squared equals. Okay. So I'm going to do 9 squared plus 12 squared minus, now I'm going to put this next set in parentheses, 2 times 9 times 12 times cosine of 25. Close parentheses, close parentheses. And I'm going to hit enter. And I get a squared equals 29.2375. All right, and we want to solve for a. So we've got a squared equals that. So I'm going to undo the square by taking the square root. And this time, hold on. It's not whenever. It's not whenever because it's a triangle. You can't have a negative side length. So we're just going to take the positive square root, okay? So I didn't forget about it. I promise you, I didn't forget whenever. But the reason why it's not a plus or a minus is because it's a triangle. It needs to be plus. Okay, so a is going to equal, and I do the square root of that number, and I get 5.4. Okay, so now I have my pair, A and A. So I can do law of sines now. So we do 5.4 over sine of 25 degrees equals, and then I'm going to go B, 9 over sine of B. All right, so we're going to cross multiply 9 times sine of 25, and then we're going to divide that by 5.4, and I get sine of B equals 0.704, and then we're going to second inverse, and this is sine because I'm trying to undo sine. So I'm going to do sine inverse of both sides. And so I do second sine, and then I fill in the answer, and I get angle B is equal to 44.77, so 44.8 degrees. Okay, so now I have 2 out of the 3 angles, so I'm going to do 180 minus 25 minus 44.8, and I get angle C, that's the final remaining one that I'm missing, is 110.2 degrees. All right, so key thing is that all 3 angles need to add up to 180. All right, next one, we've got side C, side A, and measure of angle B. All right, so we're not given the pair, so I'm looking for side B. So I'm looking for B. So it's going to be B squared equals, All right, because I'm looking for side B. Now this time, I'm going to be finding this one. So B squared equals A squared plus C squared minus 2AC cosine B. Okay, so B squared equals A squared plus C squared minus 2AC cosine of B. Okay, so I'm going to do this in my calculator. So I get 21 squared plus 18 squared minus, in parentheses, 2 times 21 times 18 times cosine of 143. Close those parentheses twice, and I get B squared equals 1,368.768. That point is a little bit light to see. All right, now I want to solve for B, so I'm going to take the square root. And again, I don't do plus or minus because it's a triangle, so it's only the positive side. And I get B equals 36.996, so 37. All right, now once I have B, I have my pair, angle B and side B. I'm going to just erase that circle because that's blocking what the actual number is. All right, so I'm going to now jot on over to law of sines. So 37 over sine of 143 equals, and then I'm going to do A, so 21 over sine of A. Okay, so we've got 21 times sine of 143, and then I divide that by 37, and I get sine of A equals 0.3416. And then I want to undo sine, so I'm going to do sine inverse. So I get A, angle A, is equal to second sine, second answer, fill that in. And it's 19.97, so we round to the nearest tenth, so that's 20 degrees. All right, so now I have what angle A is. I have what angle B is. I can find what angle C is by doing 180 minus 20 minus 143. And I get C, oh, it's an itty bitty angle, 17 degrees. All right. So last one is a little word problem. Application of the law of cosines, same idea. So we've got the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet, as shown in the figure below. The pitcher's mound, we're given, is 43 feet away from home plate. The distance between the bases is 60 feet. And then we've got the angle that it makes is 45 degrees. All right, so this is a side angle side. All right, so I'm looking for, ooh, this is a different letter, H. So I'm looking for H squared. So the way that we do this is side squared that we're given, 43 squared, plus the second side we're given, 60 squared, minus 2 times the two sides, 43 times 60, I'm going to run out of room, times cosine of 45 degrees. Okay, so now we're going to do this in our calculators. H squared equals 43 squared plus 60 squared minus in parentheses 2 times 43 times 60 times cosine of 45, close, close, parentheses, and I get h squared equals 1800.329. And I'm going to solve for h by taking the square root. And again, it's a measurement, so we're not doing plus or minus. So h is going to equal the distance between the pitcher's mound and the first base is going to equal second square root, second, fill in that answer, 42.4. All right, and now we want to do the units because this is an application problem. So my units are feet. So it's 42.4 feet away from first base. The pitcher's mound to first base is that measurement. All right, guys. So I'm going to have you guys try those last two as your turn.